record this session now. So we're going to take a look at our work for today, and we're going to start. Oh, that's the wrong slideshow. And we're going to take a look at. I'm going to close out my email too. Slide number 1. So can I get in the chat that everybody is back and ready to go? Just because I don't want to get started if people aren't back. Peyton is ready. Abby is ready. Sadie is back. Perfect. Thank you, Abby. Thank you, Adam. Thank you, Nassim. Perfect. Perfect. I need a few more people to let me know they're ready. Gabe is ready. Ian's ready. Max is ready. John is ready. Perfect. Here we go. So today we are solving systems of equations using substitution. So once again, this is sort of, so the idea was that you didn't have, in theory, you wouldn't have had exposure to substitution since last year. But that is not the case for you guys because we did substitution, solving systems of equations using substitution, during that little mini break, that mini unit back in November. So you guys have exposure to solving systems through substitution. So today should not be this crazy difficult sort of idea for us because we've had a lot of exposure already to this content. So just want to put that in your head so that it's not like, oh no, this is all new. Nope, not new. We've done a lot of this before, okay? So let's take a look at our warm-up for today. Our warm-up for today is we have a graph here that has a systems of equations on it, okay? So there's no labels on here other than like the X and the Y, and you can imply that these are positive numbers and these are positive numbers. We don't have any actual numbers though. So now what you need to do is you need to take 2 minutes right now to look at these 4 systems of equations, and you need to decide, in theory, generally speaking, would each of these or could each of these systems of equations be represented by this? Could this systems of equations be represented by this graph? You need to remember what these single variable equation lines would look like. Thinking about that, how we've learned about X's and Y's. And then for these two, you're going to have to do a little bit of movement to think about these different equations here. You're taking 2 minutes right now to work on and decide if each one of these could be, in theory, represented by this graph here. Letting me know in the chat when you get them. Yes or no. Making sure that you're looking at the values in these equations as well. Do these values make sense with where these lines are? I want you to think. Okay, we're taking another 48. I want to see what people are thinking. Let me know in the chat. Okay, we're taking another 8. Okay, so I think this guy might have been a little bit challenging for some of us. So let's take a look at what this guy is saying. So if we're looking at this first set of systems of equations right here, we have this equation of x plus 2y is equal to 8. So in theory, this first equation could work because if we were to bring this this x over to the other side, get this first equation here in the y-intercept form, this would have a negative slope. Okay, so this first equation works, but if we look at this second equation, x is equal to -5, that means it's going to be a vertical line, but it's going to be a vertical line at the x-axis of -5. So it's not going to be in this first quadrant here. It's going to be over in quadrant 2. So this guy right here is not going to be an option for this graph because of this -5 here. This x is equal to -5. So when we look at this guy here, we're not going to be able to say that this guy is a match because this -5 would be in quadrant 2 on the other side of this y-axis here. So that one is going to be a no on that one. Okay. Let me erase that. Now let's take a look at the second one here. Oh no, what's going on? Oh wait, I know what's wrong. Let's see. I have to turn this off. So this one is a no. Okay, so then if we look at this guy right here, this one has a negative slope. So that first equation does work, but oh no, this one hits at the y-axis at -1. So that means it's going to be a horizontal line here. So if I were to come over here and plot this guy, it would be down, it would hit right down here. Let me see. No, maybe not. Let's see. It would hit down here and it would be a horizontal line because it hits our y-axis. So it would be going through it would be a horizontal line for that equation. So this guy is not going to be a representation because when you draw this second equation here, it's going to be a horizontal line, not a vertical line. Also, it's a negative number, so it's going to be below this axis down here. Two sort of reasons why this guy would not work. Okay, so this guy is a no. Okay, then if we're looking at this guy right here, we could say, we could get this x by itself and it would be a positive 8/3, which could in theory, because we don't have any numbers here, this guy works. This first guy is going to work because if you were to isolate your x, you would be left with 8/3, and that in theory could fall right here. So I would say yes to this first piece in this equation here. I would say, let me just do a little bit of a work here. So I would say yes to this guy. Now I need to isolate and get my my y by itself here. So to do that, I would subtract 3x from each side, and I would have y equals 15 minus 3x. And this slope here is negative, and this equation line, the slope is negative. So this second guy here would also work. So this systems of equations could, in theory, be matched with this graph right here if we were able to get some labels on here. Nice job, guys. So this guy would be a yes. Last one here, we're going to look at this one. If we were to isolate and get this second equation so that it was just the one variable is equal to, subtract 4 from each side, y is equal to 6, that once again we would have a horizontal line at 6 here. Y is equal to 6. So this last one here would not work because the second equation would have a horizontal line, not a vertical line. Okay. Does everyone? Very good. Do we sort of see? Nice job, Gabe. Nice job for all of those ones, Gabe. Nice job. So guys, I know that this guy was a little bit challenging, but I wanted to take some time to really go through it and make sure that we can sort of make some generalizations about graphs if we're given them and systems of equations. So I know that this guy was a little bit challenging and we've never done anything like super explicit like this, but I wanted to get us some exposure to this idea. Okay, so today in class, we're going to be solving systems of equations by substituting a variable or an expression. Okay, so I'm going to talk a little bit more about that. So we're going to have a systems of equations, right? And we learned last unit that we can solve them using substitution by isolating one of our variables in one of our equations and substituting the opposite side of the equal sign in for that variable on the second equation. It's going to make more sense when we look at another example. The second one here is I know more than one way to perform substitution and can decide which way or which to substitute based on how the given equations are written. So this means we're going to have some flexibility when we're thinking about substitution. You might just be given an equation with y equals or x equals, and you can just substitute it in. You might have to do a little work to get one of the equations sort of substitutable or have one variable isolated. So we're going to have to be flexible and be able to look at and make decisions on which of the equations are we going to want to isolate for. We want to be strategic. So yesterday we were talking about methods of finding solutions in systems. We were looking at graphing equations. So we were given a systems of equations. We used that Desmos tool and we were able to graph them and calculate the solution. This is the best way to go about finding a solution to a system when you're given both equations in y equals mx plus b form or slope-intercept form. So graphing is a good way to go when you're given your equations in slope-intercept form. The solution is the point where the two equations intersect or meet or cross. So I have this guy right here. We have this example. We graphed both of those examples, and the solution to that is where they cross or intersect at 0, -1, or 1, -1. Mr. Main, use those beautiful eyes. Okay. So let's take a look at this idea of substitution. This is not the first time that we've dealt with substitution, but I wanted to sort of give us another example of this substitution sort of idea. I'm just going to make this a different color. So substitution is it's best to use substitution when one of the equations is equal to a single variable. So if either of your equations is written as x is equal to or y is equal to. Another good time to use this substitution is when you have an equation and it might not be isolated, but you have like 5x plus y is equal to 14. When you have a single variable that you can easily manipulate it and solve to isolate. So that was the two times really that this is the best way to use. The way that we do that is we solve so that one of the equations has a variable isolated, y or x. We substitute the opposite side of the equal sign in. So this one right here, for example, we rewrote it so that it was x is equal to -y plus 5. Then we take the opposite side of the equal sign, substitute it in for that variable in the other equation. So we take this whole piece right here and substitute it in for x in that first equation. Okay, and then you do your distribution, combine your like terms, and solve for that variable. The last step is to plug that new value that you got into either one of the equations to find the other variable. Can I get something in the chat from people telling me, do we remember doing this from last unit? Thank you, Naseem. Perfect. So some people are saying a little, good. We're going to get you back to full strength with that. Some people are saying yes, very good. So like we learned last time, it is a little bit of a tedious process. It takes a little bit of time, but we're going to work at the pace that we need to work at, and we're going to be okay. Okay. So let's take a look at slide number 6. Okay. So slide number 6, we have two systems of equations, and on slide 7, we have two systems of equations. Okay. So our job today, we're going to be solving these 4 systems of equations. And let's take a look at letter A. We're going to do letter A together. And we're going to take a look at it, and we're going to try to solve it the best that we can. Let me, I'm going to make this a little bit smaller. And I'm going to go like this, just so that I can see the chat a little bit better. Yeah, I know you guys can't see the chat, but I can see the chat better now. And let's take a look at this first equation here. So when we're looking at the system right here of A, what do we notice? If we want to solve this using substitution, what do we notice looking at this systems here? What's our first step going to be? Okay, Peyton said that they both start with X. Okay, that's something good to notice. So Gabe said we can input -5 for X. Abby said that we can plug -5 in for X in the first equation. So we were talking, when we were talking about this, we said we wanted to get one of our equations written as X is equal to or Y is equal to. If we look at this equation down here, we already have one that's written in that form of X is equal to. So we don't even have to do that first step because it's already done for us. Why is this not working? Oh, I have to hit the pen. It's already done for us. So that means we can take this -5 and plug it into that first equation for the X. So if I come into my box here, you can either do this on a piece of paper and take a picture and insert it, or you can type it in the box. We have this equation of X plus 2Y is equal to 8. Okay, we can plug this -5 in for our X, and we would get -5 plus 2Y is equal to 8. Oh, that was not good. Okay. So what would I do next to isolate or get my Y by itself? What would I do to each side? Nice job, Abby Waston. Nice job, Gabe. We're going to add 5 to each side because we want to get this Y by itself. So the first thing we need to do is undo that subtraction by adding 5 to each side. Okay. When I add my 5 to each side, these cancel out. I'm left with 2Y is equal to 8 plus 5, 8, 9, 10, 11, 12, 13. Okay, and then how do I get my Y by itself now? How do I isolate my Y? Let me know in the chat, guys. What are we doing to isolate or get that Y by itself? Nice job, Gwen. Awesome job, Sadie. We're going to divide. Nice job, Adam. Nice job, Abby. We're going to divide both sides by 2. Very good. So we're going to divide by 2, divide by 2. We're going to get Y is equal to how much? Very good. Y is equal to 6.5. Very good. So my final solution is going to be X is equal to -5. Y is equal to 6.5. Okay. So your job, listen closely, closely, closely. I am giving you, let's see, I'm giving you 10 working minutes to solve B, C, and D. A lot of these are not too bad for you because they have already been, let me just, I'm going to leave this up for a second because I want to make sure the work stays up here. So actually, I'm going to go like this. I'm going to, give me 1 second. I'm going to put that work back up. I'm going to put that work back up. I have it saved. I just want to move forward on here. So you're going to do C and D. For C, you might need to isolate or get one of your, do something to get that variable by itself. And then you're going to solve for X and Y. Okay, so here we go. I need you guys to take 10 minutes right now to solve B, C, and D. I'm going to put the work back up from A. Just give me a moment to paste it back in. So you're going to get started, and then we're going to come back in 10 minutes. If you have questions, they go in the chat. Oh, no. There we go. The work from A is up there. If you would like to get it copied down for yourself. Once you get your final solution, so you can go like B, X is equal to, Y is equal to. Let me know in the chat. Nice job, Kyle Kelly. Thank you for that answer, Kyle Kelly. Nice job. Nice job, Gabe. Nice job, Peyton. Wonderful job, guys. We have 7 more working minutes. You're doing fantastic. Fantastic. We have another 5 minutes and 30. I love these answers that I'm getting in the chat. You guys are doing fantastic. Keep up the awesome work, guys. And try to keep things as fractions if you can. So Kyle, that x is going to be, for number 3, it's going to be 8/3. So just keep it as a fraction for yourself, because thirds are messy. Awesome job. We're up to 4 minutes and 30. You're doing great. Ooh, nice job, Peyton. I love how hard you're working today. You're doing fantastic. I mean, you always are doing fantastic, but I'm just really proud. Nice job, Gwen. Perfect. Ooh, Mr. Mean just found a better way to do this one. Oh no, she's cutting it to the wire. Boom. Mr. Mean is so good. Oh my gosh. Scary. Ah, see, you know what? You're getting that 7.5 too. Wonderful, wonderful. We're taking another minute and 30. Because it's minus. Oh, Mr. Mean. we're taking another 30 seconds, my friends. Everybody is doing fantastic. Keep up the awesome work, guys. Okay, here we go. Let's take a look. Save here, upload. Okay, so let's look back at letter B on slide number 6. So if I'm looking in the chat, I got only a few people gave me answers for this one, but every single person that gave me answers said X was equal to 2 and Y was equal to -1. So let's take a look at the work that we could have written down / typed in the box that would have sort of helped us to get this guy done. So if you look at this equation right here, we have a y is equal to a number. We already have a y is equal to. So that means we can take that number and substitute it into the other equation to find your solution. So if you're looking at, let me just put my work in here so that we can sort of take a look at it together. And if we take a look at this work here, we can say this y is equal to, and we can substitute that into that first equation there. So when we look at it, and we look at it down here, we substitute our -1 in for x. To isolate, to get that x by itself, we subtract 13. We get -14 is equal to -7x. Isolate that x by dividing by -7. We get x is equal to 2. We don't have to do any work to find out what that y is because we already know what that y is. So we can write that final solution of y is equal to -1, x is equal to +2. Okay. You could have written it as an ordered pair like Gabe did. Both ways work. Okay, and I'm going to leave this work right here for us to sort of look at if we need it. I'm going to come back in a minute if you didn't get this work written down, and you can copy it down. Okay, so let's take a look at slide number 7. We're looking at C. The people in the chat that gave me answers for C. Let's see what people gave us. Some people were saying that for C, it was 8/3, 7. Kyle said the same thing. Peyton said the same thing. Gwen said the same thing. So let's take a look at that work that we got for this guy here. So if we look at this guy here, we have one that's almost isolated here. We have this 3x. And to isolate it, you could have, let me just get this picture in here. You could have divided each side. Oh, no, that's not what I wanted. You could have divided each side by 3 to get that x isolated, and we would be left with x is equal to 8/3. I don't know. I'm trying to talk and do this at the same time. I think that's what the problem is. Okay, let's make this a little bit smaller so that we can look at the work here. That's not what I wanted. Okay, so we can substitute, we can solve for this x is equal to 8/3. And then, so we know what our x is equal to, and we can substitute that in for our x in that first equation. So 3 times 8/3 plus y is equal to 15. I multiplied by, so you had to multiply 3 times this 8/3. So I wrote the 3 as a fraction over 1, and I cross canceled because a 3 in the numerator cancels out a 3 in the denominator. So I cross canceled, and I was left with just 8 plus y is equal to 15. Does everyone see how I did that, how I cross canceled there? Nice job, Abby. Does everyone see how I cross canceled there? Thank you, Abby. So I cross-canceled and I was left with this 8 plus y is equal to 15. I needed to isolate or get my y by itself, so I had to subtract 8 from each side, and I would be left with y is equal to 7. So I have what my x is equal to, I have what my y is equal to. My final solution, x is equal to 8/3, y is equal to 7. My suggestion to you, please do not turn 8/3 into a decimal. You will not get the right answer. 8/3 with a denominator of 3 does not terminate. Don't do it to yourself. Keep it as a fraction. Do the work out on Do the work out on the side if you need help with the fraction bit, but you need to make sure that you're keeping these things as fractions. Okay. So let's take a look at the last one here. The last one here there's two ways that we could have done it. I did it one way and then I was like, hey, I don't like it that way. There's another way that I could, in theory, do this. You could have really isolated for either one of them. Oh, let me go back. You could have isolated the equation. You could have isolated either one of the equations because either one of the equations works. So you could have taken this first one and not done any work with it, but I liked it because then in the end, I wouldn't have had to do any work. So I actually isolated the second one so that I could get just the y is equal to the 8. If you look at this work right here, that's what I did. So I isolated and I got my y by itself in the second one. And I said y was equal to 8 so that I wouldn't have to do the second round of substituting and solving. So I got y is equal to 8. I took my first equation and I substituted 8 in there. And I had written it down incorrectly, so that's why I kept getting the wrong answer. So 8 is equal to 2x minus 7. Subtracting or adding 7 to each side to get that x isolated. 2x is equal to 15. Divide by 2, divide by 2. X is equal to 7.5. Okay, so a final solution of 7.5 for that guy there. What we're going to do, ladies and gentlemen, I am going to make these pictures available to you so that you can have pictures of these final answers. I'm going to post them at the end of the teaching block today so that you can come back and check them out for yourself if you missed any of them. What you're doing this afternoon, okay, is I put a link to a video here. Okay, in the video, I go through and I think I actually do the first one with you, I believe. We go through and we substitute in and solve this guy using substitution. And then I give you 20 working minutes to actually do the other 3. And the reason I gave you 20 working minutes is because for each one of these is difficult in their own way. Like this one is nice because like you have your guy isolated. So this guy shouldn't be taking you too much time. This one shouldn't be too hard. The hard ones are on slide number 11. And I need you to work really, really hard on these guys and push yourself a little bit further than you might feel comfortable with, because these are challenging, but the numbers that you get out at the end are really nice. So you're dealing, like, for example, you're dealing with fractions here, but it works out nicely. So just push through, work hard. For these ones, if you do your work on a separate piece of paper, you need to insert your work just like I did. If you need another slide, you can insert another slide in there to put that work in, but the work needs to be there. Same thing for this morning's work. If you did your work on a separate piece of paper, please take a picture, because I'm going through and I'm checking to make sure that these pictures are in there or the work is in there. So the pictures of the work need to be in on 6 and 7, and they also need to be in on 10 and 11. In the video, I go through, the video is 36 minutes because I actually gave you 20 minutes of work time, and then I actually yes, you can type it. I actually go through all of the answers. I don't just give you the answers. I go through all the steps because these guys are a little bit more complicated. Okay, so stick with the video. This is a very important topic, and if you want to skip ahead, I put it up as just a Loom video so that if you finish early during the work time, you can skip ahead and go right to the answer section. Okay. So I need everybody to give me the full 36 today, maybe a little bit less because I don't think you're going to need 20 whole working minutes. But I need you guys to give me the whole time on the video today. It's super duper important. You can type out your work if you would like. You can do it on a separate paper and insert it, but the work needs to be there. Okay? Does everyone understand what you need to do for this afternoon? Okay, I am going to be holding a group. I'm going to put a Zoom link up this afternoon. If you want to jump in and if you need help with the substitution, I can help you out. If you don't need anything else, oh yes, I can go back to 6. I'm gonna leave 6 up for a minute. You can head out to science if you would like. If you want to stay in for a minute to get things written down, you can do that as well. Have a good day, guys. I will see you tomorrow. Bye, guys. I will see you all tomorrow.